Hey students, how are you all? And welcome to IMST online classes. Okay, so in the last video we studied some of the parts of human eye. Okay, and what is their function. So let's see how images form in our human eye. So here we have two different cases. First, you can see in this case the object is at a distance placed. So the light ray after refraction they form the image here. Okay, can you recall what was the name of this part? Okay, this part, this region is called as Fabio centralis. Okay, Fabio centralis, or this is the region of the yellow spot. Okay, and this is the region of blind spot. Okay, here in the second case, the object is little bit nearer. Okay, so the image is formed here in the yellow spot region. Now, what is the difference in both this case? In these two cases, in one case the object is nearer to the human eye, in the other case the object is far away, little bit at a distance. So, what is the change basically in this structure? You can see is the size of the lens. In this case, you can see the size of the lens is increased. Here it is quite decreased and it has become thicker. Here it is thin. Aperture, this is called as aperture, this is thin, in this case it is thick. So this work is generally done by the ciliary muscles. Okay, so the ciliary muscles, they adjust the human eye, okay, based upon the distance of the object. This ability of human eye is called as the power of accommodation. Okay, note it. Power of accommodation. The ability of human to adjust its focal length. Right? Okay, so what is power of accommodation? It is the ability of our human eye to adjust its focal length by either contracting or relaxing the eyelids, and this contraction and relaxation is generally done by the ciliary muscles, due to which instantaneously we can change our sight from a distant object to a nearby object. Okay, understood? Now, if you recall the image formation in case of a convex lens, right? If you recall the image formation in a convex lens, then you might remember the special case, the last case, that is when the object was between focus and optical center. In that case, the object formed was virtual, right? It was formed at the same side. So in this case also, if what you can say, if virtual image has to form, then in this case object is in this side, so the image also will be formed in this side. But here there is no screen, right? Retina acts as the screen, but this side there is no screen, so we can't see an object if the image is, we can't see the image if the image is virtual. So that means our human eye must have a low the minimum focal length at which we can see an object. That minimum focal length is called as the least distance of vision. Okay. Least distance of vision means the minimum distance at which we can see an object clearly. That is the least distance of vision. On an average, this least distance of vision in human beings is 25 centimeters. So that means if an object is at a distance of 25 centimeters, we can see it very much clearly. If the distance of the object is less than 25 centimeter, then the image will be a little bit blurred. We can't see it clearly. Okay. And it is a general sense. Okay. On an average, the least distance of vision, okay, for human eye on an average is 25 centimeters. So this is the least. What is the farthest? Farthest distance what we can see a human eye is infinity. Okay, a human eye doesn't have a what you can say the farthest limit. We can see up to infinite distance. Okay, for example, see, we can see a celestial objects like moon, the sun, which is 128 billion kilometer. We can see it, right? Stars, which are even farther from us. That also we can see with our naked eye. So that means our farthest point of our human eye is infinite. Okay, provided that there is no blockage in between. Okay, now pause the video and note it down. So we can compare our body to a machine, right? Because just like machine has different parts, our body has different parts so as to can function properly. Similarly, the human eye also can be compared to a machine. It also has different parts, and just like a machine, if a part malfunctions or doesn't work properly, the machine also shows some problems. Similarly, in case of human eye also, if some part of the human eye does not work or get damaged, the functioning of the human eye gets affected. So there are a lot of problems related to the human eye, but here we are going to study some problems related to the vision. Means by which the vision is generally affected. Okay, so these are called the defects of vision. Defect of vision is divided into two types: major defect and minor defects. Major defects includes myopia, which is also called as short-sightedness, and hypermetropia, which is also called as long-sightedness. Minor defects includes presbyopia, astigmatism, and scoliosis. Now let's see what is myopia. Myopia, which is also called as short-sightedness. Why it is called as short-sightedness? Because the person who is suffering from myopia, a myopic person, can see the near object clearly with no problem at all. But if an object is at a distance, then that person is unable to see that. That's why it is called as short-sightedness. Can see near objects only. Now the question is, why does it happen? The reason is, it happens due to many, it's actually a birth problem. By birth it occurs, and there are many reasons behind it, but one of the common is if the lens gets thicker. Generally for our distance vision, the farthest point is infinite, but for a myopic person, if the lens becomes thick, and due to which the focal length, that is farthest point, it becomes finite. Okay, so that means for a myopic person, if this is the finite point, means the person can see up to this much distance clearly. If an object is beyond this one, then the light which is coming from the farthest point, the refracted ray in this case will intersect before the retina. So since the image is found before the retina, the eye cannot detect, or the optic nerves, they cannot detect the image, so the brain also cannot sense it. So that's why we are unable to see. The myopic person can't see distant object. Understood? Now the question is, how can we cure it? It is not that these defects are uncurable. Most of the eye defects are curable. Okay? Myopia can be cured by using concave lens. Okay? Concave lens. Not just that doesn't mean that you will take any lens and you will use it. Okay? You can refer to an eye specialist and they will refer you what will be the focal length of that concave lens. So what will happen? So generally, if a concave lens is placed in between this eye, so what will happen in this case? The parallel rays, they will, as we know, they will diverge. converging ray, when they interact with the mirror, they will converge at the retina, forming the image. Okay. So what will happen? The concave lens, it will make the object to come nearer. Okay. As you can see, the object was beyond the distant vision of a myopic eye. But due to this concave lens, the image formed here, now this image will act as an object for this lens, for the eye, and since the distance vision is here is the distance vision, and the object came near, so you can easily detect the image. So by this method, generally the myopic problem is corrected. It is corrected by using concave lens. Understood? Good. Now, moving on to the next major defect of vision, that is hypermetropia. Okay, hypermetropia, as you can recall, is also called as long-sightedness. Why? Because the person suffering from hypermetropia can see the distance object clearly. But not the near one. Okay, so it is kind of just opposite of myopia. In this case, the person can see the near object. Anything which is nearer to the person, he can see. Okay, in order to see, he needs to keep the object at a far away place. You might have seen some person, they will read keeping the object at a distance because they are suffering from hypermetropia. Okay, so why generally it is caused? It is also a birth disease. It is generally caused from birth only. One of the reasons, the cause is due to thin lens. Okay, if somehow the lens becomes thin or completely due to some action of the ciliary muscles, it is completely stretched, so it becomes thin permanently, then this problem arises. Okay, so what happens in this case? In this case, generally the near point, that is the least distance of vision, it shifts to a farther point. So what happens if this is the near point? If an object, for an hypermetropic person, the near point shifts here. So this is actually the near. This is the near point for a normal person. Near point for normal person. This is the near point for a hypermetropic person. Okay. Near point. So at this place, the person, or after this only, the person can see an object clearly. If a person is suffering from hypermetropia, he can see the object if it is at a distance of from here or farther from this. If an object is kept nearer to this one, like here, if an object is kept here, he can see. Why? Because in this case, generally what happens? Okay, the image formed is generally beyond the retina. Okay, the image will be formed here, and as there is no retina or the screen, there is no screen there, so the eye, it cannot detect the image, right? So this is the problem. How to cure it? Since it is the opposite of myopia, so the cure is also the opposite. It is used, it is cured by using convex lens. Okay, it is cured using convex lens. So what happens if a convex lens of appropriate focal length is placed here? So what will happen in this case? It will form after refraction. After refraction, it will divert the light in such a manner that in order to form the image, just a minute. what will happen that this light source after falling here, they will refract. And how they will refract? They will refract in such a way such that it will form an image here, okay, at the distance point. So in this case, the image can be detected by the human eye. Let me make it a little bit more clearer to you. Okay, so you can see here, so this is actually the distance, the nearest point for a hypometric person. So when the object was here, we cannot see it because the image was formed beyond the retina. So when we place a convex lens in front of the eye, so the convex lens forms a virtual image of this object near the distinct or after the nearest point. So this helps in forming this image. Okay, now here it forms an image of this object. This image acts as an object for the eye lens, and the image is formed in the retina, which makes it easier to see. Okay, so if a person is suffering from hypermetropia, he should use a convex lens. Now, how to know whether a person is suffering from hypermetropia or myopia? Recall what you have studied in the light chapter, okay, for the power of a lens. For convex lens, the power is always what? It is positive. So, if a person is wearing a specs having power positive, that means he is suffering from hypermetropia. And if a person is wearing a specs having power in negative, then he is suffering from myopia. So these are the major defects of vision and how it is cured. Okay, so let's move to the next one, the minor defects. Now let's see some of the minor defects of vision in human eye. First is presbyopia. Presbyopia is a common problem in old age. Okay, in old people, that is a very common problem. So generally what happens in this case, since the muscles becomes a little bit weak and old, the person suffers from both hypermetropia and myopia, kind of means he can't see anything which is at a farthest distance and anything which is completely nearer, means smaller objects also. So in this case, generally to cure it, a combination of lenses is used. Okay? Combination of lens. As you can see here, okay, in this case, concave lens and convex lens are used in a combination. The concave lens is used to see the distance object clearly, and the convex lens is used to see the near object, smaller object, which and this is mostly used for reading purpose. It is also called as reading glass for old people. Okay, so this problem is cured using combination of lens. Presbyopia. Okay, another minor defect is astigmatism. Astigmatism is a kind of problem in which the muscles, the cornea, it occurs generally due to a problem in the cornea. Due to the problem in the cornea, the person cannot see an object in the vertical or the horizontal plane. And this problem, astigmatism, is generally solved by using cylindrical lenses. Cylindrical lens. Okay, and the third one, phoreas. Phoreas is a kind of problem, okay, from birth only. It generally occurs if the muscles becomes which is holding the lens, like ciliary muscles, if they become weak and they can't hold the lens in place properly. So due to which the person generally sees two images of a single object. Okay, it generally sees two images of a single object. This problem is called as phoreas. Two images, one object. Okay, generally it is cured by using prismatic lens. Lenses which is generally prism shape. Prismatic lens, generally it is represented in a triangular part. By using this type of lens, it is cured. So these are some minor defects. And also there is a problem which occurs during the old age, which affects the vision, is cataract. Cataract is a kind of problem which is also common in old people. generally due to deposition of some chemicals on the eyelids, okay, the vision becomes blurred. Deposition of some white color substance, the vision becomes blurred. So it can be cured surgically by removing the lens. Okay, this is a common problem. It is called cataract. So these are the problems or the defects related to vision. Last but not the least, always remember that human eye or the eye of a human is quite an important organ for all human beings. We give more priority to our eye than any other sense organ. So you can try to think of the person who are blind, those who have some eye problems. What are the different kind of problems they suffer in the day-to-day activities? So it is always generally requested to all the persons to donate their eye. And for eye donation, there is no minimum age required. Any person at any age can donate the eye. So generally, generally the eye is removed after the death of the person. So any person, if he or she is not suffering from any kind of communicable disease or blood cancer, like leukemia, hepatitis B, such kind of problem, that person can easily donate his or her eye to a healthy person. And remember, if you donate a pair of human eye can save 2 corneal blind people. Okay, understood? So this is for now. Have a nice day. Thank you.